Hey guys, today we are going to do 5-1 polynomial functions. Our objectives are to classify polynomials and to graph polynomial functions and describe end behavior. Essential understanding: a polynomial function has distinguishing behaviors. You can look at its algebraic form and know something about its graph. You can look at its graph and know something about its algebraic form. Some key vocabulary before we get started. A polynomial is a monomial or a sum of monomials. The degree of a polynomial is, if we have a polynomial in one variable, it's the greatest degree among its monomial terms. So it's the highest exponent. A polynomial function with the variable x defines a polynomial with the variable x defines a polynomial function. The degree of the polynomial function is the same degree as the polynomial, still the highest exponent. Standard form of a polynomial is when we put the terms in order with our highest exponent going to our lowest exponent. Some names we need to know while classifying polynomials. We classify polynomials by degree and by number of terms. So 0, if we have no variable, it is called a constant. 1, exponent of 1 is linear. Exponent of 2 is quadratic. Exponent of 3, cubic. 4, quartic. 5, quintic. And then if we have the number of terms, we only do 1, 2, 3, 4, or more. So 1 is a monomial, 2 is a binomial, 3 is a trinomial, 4 is a polynomial. You can say the number of terms. So if we had 7 terms, then we would say a polynomial of 7 terms. Classifying polynomials, we first need to write each polynomial in standard form and then classify by degree and by number of terms. So I'm going to rearrange this as 9x squared plus 3x plus 5. Since my highest exponent is 2, this is quadratic. And since I have 3 terms, this is a quadratic trinomial. Going to rearrange in order from highest to lowest exponent and combine like terms here. So I have x to the 4th plus 4x squared plus 4x minus 12. My highest exponent is 4. Therefore, it's quartic. And since it is 4 terms, it is a polynomial of 4 terms. Here we're talking about turning points. So the degree affects the shape of its graph, determining number of turning points and end behavior. So we are increasing on our graph when our y values and x values are increasing, and we are decreasing when our y values are decreasing and our x values are increasing. X values are increasing means we are moving towards the right. If we have a degree of n, we can have at most n minus 1 turning points, which is when we go from either increasing to decreasing or decreasing to increasing. Right there would be our turning point. And behavior of a polynomial is determined by 2 things. We need our first term in standard form because we need the coefficient and the degree of the exponent. So the coefficient is positive or negative, and if the degree or the highest exponent is even or odd, then we are going to determine what our end behavior is. Describing end behavior, so we're going to make sure we're in standard form, and then figure out if it's positive or negative, even or odd, and determine the end behavior. So if we have 4x cubed minus 3x, my first term is 4x cubed, which means 4, my leading coefficient is positive, my exponent is 3, which is odd. So I need to look at positive odd on my chart. Positive odd on my chart is right here, and that would be down, up. So on the left, we would be going down. On the right, we would be going up. We are in standard form for B. So I'm looking at my first term. It is, my leading coefficient is negative. My exponent is even. Therefore, I'm going negative, even. And on my chart, that tells me down, down. That's all for today.